Hi guys. So yeah, this is my topic. I'm going to be teaching, or rather presenting, about a way to talk about oceanographic topics in a more funny way. I was told I needed socks. So here we go. A nice sea shanty to kick us off. So here's my topic: mayhem in the oceans. Smashing plates, giant waves, power bergs, and soothing currents. The first point that I wanted to make is that we've learned through this class that we are all connected. To each other biologically, to the earth chemically, to the rest of the universe atomically. And few things more so than the ocean. You can look at all of these processes and the ways that they are interacting and working with each other. And a main point that I want to get across to you guys today is that kind of like chemistry, Le Chatelier's principle, if you change anything, everything else changes and has to adapt. One comment about my presentation is that I'm going to need a little bit of help from you all. So I have a question. Who likes whales? Beautiful. I saw you two first. In the next 30 seconds, I want you to write as many species of whale as you can. Space whales count. Meanwhile, I'm going to introduce the 4 topics that we can talk about. The rest of you, whoever wants, you can pick any of these 4 topics. You can pick, you can pick ice, currents, hazards, or plate tectonics. Any order you want to go in, I can accommodate. The file is really cool like that. So does anyone have a preference of where we want to start? And it doesn't matter. We can go anywhere from anywhere.
Ice. Ice.
Yeah.
Ice. Good choice. And pause the time here before we start.
Yeah. Oh, wait, no.
Oh, no, pens down. So we've got Baleonoptera.
Words I think
Beautiful. Orca, blue whale. Oh, you went like scientific. Beluga. Is that even a whale? It is a whale.
Cool.
Homerus whale. Beautiful. So that's 5. And then here we've got blue, humpback whale, fin whale, minke whale, bowhead whale, killer whale, beluga, pygmy whale? Pygmy whale. And pygmy sperm whale. And sperm whale. I love it. You get an award after the thing. Okay. I have some gummies because that's called a gummy suit. Let's start with ice. So ice is one of my favorite topics in the ocean. As you can see, the environment that ice facilitates is phenomenal. The most cool thing about ice is really, really obvious. It floats. Just try to imagine what the world would be like if ice didn't float. It's debatable and conceivable that life wouldn't even have existed. But because it floats, it has the capacity to change climate and to create habitats for all myriad of sorts of animals. And because of how dynamic it has been throughout Earth's history, there have been 6 ice ages. By the way, only 3 of those have happened since animals could walk on land. So ice ages have a huge geological legacy on this planet, and this blue planet often looks a little bit more like a snowball. How does this relate to us here in the Puget Sound? Well, just in the last glacial maximum, 17 to 20,000 years ago, we had a pile of ice over Seattle 6 times higher than the Space Needle, 1,000 meters. And with all of this dynamic motion of ice back and forth through ice ages and periods of warming, we now successfully, TIERS, have created a Northwest Passage. People and explorers spent decades looking for a way to connect through a Northwest Passage, and it just took a little climate change. And so now every year since 2007, we've had significantly reduced ice in the north, which, as we've pointed out, has great benefits for economic things. And that brings us back. Does anyone have a desire for another topic?
Hazards.
Hazards. Let's go to hazards.
Maybe play tectonics in the water.
Beautiful. As you can see, art has an important part of the ocean. This is the wave of Kanagawa, a Japanese representation of a tsunami. Here we have a little bit more of a realistic depiction. This is from the Tohoku earthquake that happened. And this video just shows water inundating for minutes on end. But there are other types of ocean hazards as well. Similar processes work across the whole ocean to form currents, but they also form huge storms like this. Now, I don't know if any of you have ever thought about counting measurements in metrics of nuclear bombs, but a storm like this that's raining releases as much energy in a minute as 10 Hiroshima bombs. And that's just a stupendous amount of energy, and that's not even the best part. Earthquakes, you'll recognize this. We are in a building right about there. Here we've got the ocean plates and the continental plates subducting in a locked zone. What does this produce? You all know. Earthquakes. And so if a magnitude 9 earthquake is released, the amount of energy far exceeds that of the storm that I was just showing you. Enough to knock down bridges. This is a picture from a California earthquake, but we know that not only with magnitude, but also how vulnerable Seattle is with all the bridges, that this will have a significant impact on us. But apart from that, there are also plenty of other hazards in the ocean. Pollution is particularly one we've talked about throughout this class. Here's another artist's depiction of the Great Wave made of ocean plastics. Is that not going to work?
Okay.
Oh, it does work.
No, no.
Thanks. This is just a little slow. And so we've had connections, right? Ice and the way that ice ages or climate change is yet another hazard. So we see connections in all of the ways that these topics are interacting. Who's next?
Currents.
Currents. So the same processes that cause some of these hazards and cause some of the motion in the ocean is dependent upon these currents. And I can sum up about 90% of everything that has to do with currents with this little depiction. This is all about density. Density can be caused by dissolved solvents making the water literally heavier. And if it's heavier, it... Nice. And if it's lighter, what about hot water? Does that sink or float? Floats. Warmer water floats, colder water sinks. Blue, cold. Red, hot. I've used different salinities, but pay attention to what happens when I lift this middle slide. Right? These motions are analogous to the exact same things that cause huge climate variations driven by this thing called thermohaline circulation. What does that mean? That just means temperature, salt, moving around. This circulation goes around the entire planet in 1,000 years. That means if you were to dump a neutrally buoyant orange into this conveyor belt, it would not even have gone around once since white people arrived on this continent. And there are smaller currents as well. These ones are, you can see distinct gyres, and the way that all of these move around are based on wind patterns, and a thing called the Ekman spiral. I know this looks all academic and bleh, but what direction do toilets flush in Australia?
The opposite way.
The opposite way. And why is that? That's because of something called the Coriolis Force. Because the Earth is moving, we've got all these, any motion in the northern hemisphere is deflected to the right. Anything in the southern hemisphere is deflected to the left. That means if wind blows, the net motion of water is not actually with the wind, but to the right of it in the northern hemisphere. And that's the type of thing that drives all of these surface currents. And these surface currents actually have a huge impact on the ocean. They create huge mountains of water. I say huge because this is thousands of kilometers across. This dark red here is up to 1 meter above sea level, whatever that is, and these troughs here are up to 1.5 meters below sea level. These differences caused by currents are exactly what are exactly the huge impacts that currents have.
We're on a very tight timeline. There's another group coming in here in about 7 minutes.
Beautiful.
Whether we're here or not.
I'll be done by then. That leaves tectonics. So if you were to shrink the Earth down to the size of an apple, all of the crust would be thinner than the skin on that apple. So we think of these continents that we're standing on, even the oceans, as these huge, deep, these features, but this is just this soggy little film floating around on this boiling stuff, and it's all mashing together and being beautiful and destructive at the same time. These plates are subducting and converging and slipping past one another, and they've done so for millions of years. These continents are just drifting across this thin film that we call the surface of our planet. And this also, it's all interconnected, has huge impacts on ocean climate, on ocean currents. Look at this, for millions and millions of years we had an equatorial current. The Earth really likes that. That did crazy things in terms of ice ages, all dependent on currents and things like that. So here's Hiroshima. This is just an energy diagram. This is the Tsar bomb, significantly bigger. The difference between Hiroshima and the Tsar bomb, the biggest amount of energy humans have ever released in one blow, is the same difference between the Tsar bomb and a magnitude 9 earthquake. So despite the fact that these are thin little films of Earth, they're all floating around. And these forces are right on our doorstep. This is the Wanda Fuca plate. Here's our little axial seamount. Again, we're just off the screen there. And these tectonic and geologic forces impact things far beyond what we ever thought was possible. This is a hydrothermal vent system off of the axial seamount. Just discovered 40 years ago. This entire biome, this biosphere, that is a host to life that was never even thought possible before this time. Water coming out hot enough to melt lead, building up chimneys. This is a 19-meter chimney called El Guado. And so once again, it's all connected. There's a quote from John F. Kennedy that says, our salt, our sweat, blood, and tears all have comparable salinities to the ocean. We are the same thing as the ocean. We come from the ocean, and if we don't learn how to get back to it, we're in serious trouble. So I'll leave you with a quote from my favorite poet, Mary Oliver. I go down to the shore in the morning, and depending on the hour, the waves are rolling in or moving out. And I say, oh, I am miserable. What should I do? And the sea says, in its lovely voice, excuse me, I have work to do. Thank you.